Okay, for Math 3, this is going to be extra credit on solving quadratics, solving absolute value equations, and solving a radical equation. So to get the full points for this, you have to copy the notes, but then also do these textbook practice problems. And I think this adds up to just about 9, so it's not that bad. Okay, we're going to go through these quickly. You have to copy the notes and then do the practice on lined paper. So solving quadratics in vertex form. This is called vertex form because I can see that the new vertex of the parabola is 3, 1. That's why it's called vertex form. And we're trying to find the x value when the y value is -3. So here's how you do it. We're going to isolate the letter x, the variable, which means we need to remove all these things around it using inverse operations. And when you're doing that, when you're solving an equation, you start with the things that are furthest from the x, and that's what you move first. So we can't really do anything with this -3 or this square yet. We need to move this 1 to the other side. So we're going to move it to the other side by subtracting it. So we're going to subtract 1 from both sides of the equation. So now we have negative x -3 squared equals -3 minus 1 more is -4. All right, to undo this square, we have to take the square root, but we can't do it with this negative here. So how do you think we're going to get rid of that negative? If it were a 2, we would divide by 2. So because it's a negative, we're going to divide by -1. And the negative divided by the negative is a positive. So this is what we have. X -3 quantity squared equals 4. Okay, so is the x by itself yet? No, we have to get rid of the 3 and the 2. What are we going to do first? Well, the 2 is further from the x, so we're going to do that first. What's the inverse operation of a square? So the inverse of a square, exponent of 2, is a square root. So watch how I take the square root of both sides. Okay, so square and square root undo each other. So you get to go hiya, okay, like a ninja. Hiya, the square root cancels the square, and we get x -3. Here's a little reminder though. Whenever you're solving for x and you take a square root, you're going to have 2 solutions, one positive and one negative. So the square root of 4, we're going to write plus or -2. Okay, is the x by itself yet? No. Let me move up here. So we have x -3 equals +2 or x -3 equals -2, like that. And we have to solve both equations. So inverse of -3 will be +3. So the answer here is 5. X equals 5, or x equals -2 plus 3 is 1. All right, so these are parabolas, so it's going to hit this y value at 2 different x values. That's how you do that. Let's do another example. This one doesn't have a negative in front, but we have the -3, so how do you move the -3 to the other side? We're going to add 3, add 3. -3 plus 3 is 0. -3 plus 3 is 0, but we're going to write it down. Don't leave it blank. Okay, if we had a number in front, we would divide it, but we don't. We have the square, so what undoes the square? Inverse of square, square root, square root. All right, now I just told you put plus or minus, but does 0 have a plus or a minus? No, 0 is neither positive nor negative, so we are only going to be left with one solution here. And how do we get the x by itself? We're going to add 4, add 4. So we have x equals 4. So that's only going to have one answer, which means if it's a parabola, well, it is a parabola, then the reason why there's only one answer is because it must be the vertex. So the vertex has one x value and one y value. So that y value would be -3, okay? X equals 4, y is -3. Whereas this example up here, it had two x values. Just as an example, this doesn't match this one, but if the y value was here, then the two x values would look like that, just as an example. Okay, let's go into solving absolute value equations. So the first thing we need to do is we need to isolate the absolute value symbol, okay? So if anything is on the outside of the absolute value, we need to move it. Just like anything on the outside of the parentheses, we moved that first. So do you see something on the outside? We see this +8. So we're going to move that to the other side by subtracting 8. Oh, I didn't pause. You guys you need to pause in order to write the question down. So do that and then come back. Okay. So now we have 3x minus 2 equals 1 minus 8 is -7. Okay, here's where students want to just keep going, but we have a big but. Okay, but I won't write that down. But can an absolute value ever equal a negative number? No, so no solution. Anything in the absolute value it has to be greater than or equal to 0. Okay, it can't equal negative number. So that's a funny one. We just stop and we can't actually solve it. All right. So here's another example where we do get to solve. So is there anything outside the absolute value that we have to get rid of? Nope. So after you isolate the absolute value, now that it's by itself, it's isolated, you get to do two equations. So 2 lines means 2 equations, and I kind of do like an airline attendant, okay? My hands are super big on your screen, but if you go 2 lines means 2 equations, like when you're on an airplane and they tell you to exit, like that. So that's what I think about in my head. 2 lines, 2 equations, here we go. And the inside must stay the same. And if you forget that, you can sing a little song. The inside stays the same. The inside stays the same. When you're solving absolute value, the inside stays the same. So if the inside stays the same, then what changes? Well, that's the 8. So we're going to have one equation with positive and one equation with a negative solution. All right, now we just get to solve 2 equations for x. And I'm going to stop talking and just solve in peace. Still with me? All right, what would that look like on a graph? So you guys, I'm not graphing this to scale, I'm making this up. So this graph doesn't match either of these. How would you get no solution? You would get no solution when you're talking about a y value that's below the curve, the absolute value. This would be no solution. So this pretend y value never touches the graph. How would you get 2 solutions? Well, if this y value, and in this case it was 8, so this y value touches or crosses through the graph at 2 places. That would be 2 solutions, okay? That's why on this one we had 2 and this one was no. All right, let's go to solving a radical equation. So pause and copy down these 2 examples. So again, we're just using inverse operations, inverse ops, okay? And before we touch the square root, we're going to move the 4. So we move the 4 by adding it to the other side. Okay, now I have this square root symbol. So what is the inverse? We try not to say opposite anymore, okay? So what's the inverse operation of the square root? Oh, look, it says ops, but that's inverse operation, okay? But sometimes I get confused if operation is 1p or 2. I don't know right now. What's the inverse operation of a square root? The inverse operation is a square, okay? A power of 2. So to cancel, I really shouldn't say cancel. To get rid of this square root, we're going to square both sides. All right. Calculus ninjas, ready? Square root and square, you go, hi-ya. They cancel each other out, and we get 2x plus 5 equals, what's 7 squared? 49. Yep. Okay, so now you just solve for x, which we know how to do, right? I don't think I need other colors to do that. I don't think that equals goes there either. If I'm showing my work, I'm going to subtract 5 from both sides. So I get 2x equals 44, and divide by 2. So x equals 22. Isn't math fun? All right. Same idea, but what do we have to do first? We have to isolate the square root before we can use the inverse operation. So right now the square root has a 6 in front, but it's 6 plus. If it were 6 times, we would divide 6. But because it says 6 plus, we're going to not divide, we're going to subtract. So we have 3x plus 1 equals 11 minus 6 is 5. And now inverse. What's the inverse of a square root? Inverse of a square root is a square. Isn't it good to watch a video? Because like if you were just look at a picture of this, you wouldn't really understand what was going on, because it should be confusing now that you have now the square and the square root. But we just put the square there, this is in action, and say hi-ya. Hi-ya, your calculus ninja karate chop. And we get rid of the inverse operation. So 5 squared, 25. La da 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 da. What song do you sing while you solve equations? I sing this rap song that I don't even know, but somehow it goes in my head. Does that go in evenly? Isn't this nice? They're all coming up as integers, but they could be fractions, okay? All right, there you have it, some examples, but you have to do the notes and this. But you don't have to, because what is it? It's extra credit. It's a happy Labor Day, extra credit. Laboring on Labor Day, but I'm paying you with extra credit. Thanks, guys. Bye.